sklearnmetrics multi-label confusion matrix. Description: the multi-label confusion matrix function calculates a confusion matrix for each label in a multi-label classification problem. It's used to assess the performance of your model on each individual label, providing insights into where your model excels or struggles. Inputs: Y true, the true labels for the data, represented as a 2D array where each row corresponds to a sample, and each column corresponds to a label. The value at each position indicates the presence or absence of the label for that sample. YPRED, the predicted labels for the data, following the same structure as Y true. Outputs: confusion matrix, a list of confusion matrices, one for each label. Each confusion matrix is a 2x2 array, representing the following: 0, 0 true negatives Tn, the number of samples correctly classified as negative for the label. 0, 1 false positives A, the number of samples incorrectly classified as positive for the label. 1, 0 false negatives Fn, the number of samples incorrectly classified as negative for the label. 1, 1 true positives Tp, the number of samples correctly classified as positive for the label. Steps: the function iterates over each label. For each label, it extracts the true and predicted values for that specific label from the Y true and YPRED arrays. It then calculates the confusion matrix using the extracted true and predicted values. This process repeats for every label, producing a confusion matrix for each. Metrics: accuracy, the proportion of correct predictions for a label. It's calculated as TPTN/TPTN/Fn. Precision, the proportion of positive predictions that are correct. It's calculated as TPTPA. Recall sensitivity, the proportion of actual positive cases that are correctly identified. It's calculated as TPTPFN. F1 score, the harmonic mean of precision and recall, providing a balanced measure. It's calculated as 2 precision recall. Visualization plots. Confusion matrix heat map, a visual representation of the confusion matrix, using a heat map to show the distribution of true and predicted values. This allows for easy identification of patterns and areas for improvement. ROC curve, a plot of the true positive rate TPR against the false positive rate FPR for different thresholds. This can be used to evaluate the trade-off between sensitivity and specificity. Fine-tune parameters. Labels optional, an array of labels, specifying the order in which the confusion matrices should be returned. If not provided, the labels will be inferred from the data. Uncertainty methods. Confidence intervals. You can calculate confidence intervals for the metrics derived from a confusion matrix, using methods like bootstrapping or hypothesis testing, to quantify the uncertainty in your model's performance. Challenges and fixes. Challenge 1: handling imbalanced datasets. If the number of samples for a particular label is significantly different from the other labels, the confusion matrix might not accurately reflect the model's performance. Sample use case that resulted in challenge 1: a dataset with a very small number of positive samples for a specific label compared to the negative samples. Fixes to challenge 1: use appropriate evaluation metrics instead of accuracy. Consider metrics like F1 score, precision, and recall, which are more robust to class imbalance. Resample data techniques like oversampling minority class samples or undersampling majority class samples can help balance the dataset. Use cost-sensitive learning. Adjust the model's learning algorithm to assign different costs to errors on different classes. Challenge 2: Interpreting multilabel confusion matrices. The output of multilabel confusion matrix is a list of confusion matrices, one for each label. Understanding the meaning of each confusion matrix and how to combine them to evaluate overall performance can be challenging. Sample use case that resulted in Challenge 2: a multilabel classification task with a large number of labels, leading to a complex interpretation of the confusion matrices. Fixes to Challenge 2: visualizations utilize heat maps, ROC curves, and other visualizations to visually represent the confusion matrices and their relationships. Label-specific analysis: analyze the confusion matrices individually, focusing on the performance for each label. Aggregated metrics: consider calculating aggregated metrics, such as macro-averaged or micro-averaged precision, recall, and F1 score, to get a more holistic view of performance across all labels.